Here I go. I can start from the left to right building these, but I'll just start over here. Which side of this do I use?
Right.
The one. Now watch. Where do I go? Go up to where? The curve. When I hit the curve, I what? Stop, and I cut over that region. So look. Overflow. Look, I'm overflowing that thing. See? Overestimation. Where's the next one? See the image? Go up, stop, cut over. I'm telling you, when it comes to this stuff, if you just take the extra second or two to build this graph, you'll know the answer. Some of you do it, in your head. It doesn't take long to draw this.
So for this one, you're going all the way up to the curve, but the other one you really.
That's right, you got it.
So if it's right, you're going all the way
Yep,
up to the
you got
curve,
it.
and the other one.
That's right. All right, what's the width of each one of these? Well, the widths are the same, but I want to help me get these lengths. What are the lengths?
So length is.
For the first one,
One,
I plug it, see, these numbers are important. I took this one and plugged it where?
one.
Into t squared, right? And when think about this, I could have given you a sine curve, can I? Right? It could have been a sine curve. You would have get sine of the number, sine of 1 or something. But I'm plugging 1 into that to get the height. What is it?
One.
The next one is
2 square. 3 square, 4 square.
there's only one thing bad about these problems. They can be a little tedious, right? Especially when they say n equals 16 and you gotta plug in fractions. Yeah. Or the worst is when they do trig functions, because then you gotta get out the calculator and get the sine of a half, sine of 1 radian, sine of 1 point, yeah, I know. So when you keep that in mind when you practice the problems I listed. Kel, when I listed those practice problems, everyone, you're doing those practice problems, the ones where it's like a trig function or e to the x squared, and you're like, oh man, I gotta do e to the 1/2 squared plus e to the 3/2 squared. It can get a little, what's the word? Tedious. You follow me? So expect that. I didn't want you to go, ugh, drive yourself crazy with some of those. You understand the concept, right? All right, now what's this all come out to be?
30.
16 and 9, 25, 29, 30. Now, who in here has a ballpark idea of what the answer should be roughly? If a right
16.
Riemann sum's 30,
13.
overestimation. Left Riemann sum was 14, underestimation. What would be a good guess? Yeah, you're onto this. Now, everyone, do you agree with this? The more and more and more rectangles we build, the smaller the error. And the idea of send this to how many rectangles? An infinite amount?
4.
Do you follow me? Like, what would really kind of give us an idea of this? You're like, how many rectangles? The mathematicians who came up with these formulas for like these integrals repellers you're thinking about, they're like, send it to what? An infinite amount of rectangles. You follow me? Cool. Hey, but so far so good? Now there's one other technique we're going to talk about because this is the most popular. Throughout Calculus 1, Calculus 2, and Calculus 3, what method is used the most often in terms of Riemann sums? The midpoint rule. That means you don't use the left side to build it. You don't use the right side to build it, you use the what?
Mean.
The midpoint. So how about this time everyone, just to save some time, how about I say n equals 2 and I want you to use the midpoint rule. You'll know this, and when you're in Calc 3, you'll be in Calc 3, you'll be like, oh yeah, midpoint rule, I got it. If you understand it, you'll have to do those. I need a whole new picture, huh? Believe it or not, everyone, you're like, I don't feel like, please draw the picture. I think it helps you make sense of it. Now, I'm going from 0 to 4, because this says go from 0 to 4.
Mhm.
I'm using the midpoint rule, but I'm using how many subdivisions?
2.
2. Now, how does the author write that? He doesn't use L, he doesn't use R, he uses what?
M.
But not every textbook does it. Most just find it using the midpoint rule, and they have to tell you how many subdivisions though. You do cringe when they say 20 though, because you're like, 20? You get out Microsoft Excel, right? Then, where should the first one go from? There's only going to be 2 of them.
2.
Yeah, from 0 to 2, right? So where's the midpoint? Between 0 and 2.
1.
So when I build this rectangle, do you agree? You're saying this is the width right here. Subdivision 1, right? Subdivision 2. But you're saying use the midpoint of this, would be at the 1. Now watch, I'm gonna follow the same rule. At 1, I'm gonna build my height. I'm gonna build the height of the rectangle. But when I hit the curve, I stop. So watch this. Stop. Now what do you gotta do? You notice you gotta cut left and cut right?
If you
Part of it's gonna be what?
left.
Overestimated. The other part's gonna be
Underestimated.
underestimated. You'll probably understand why midpoint rule is the most popular, because it seems to be most effective in one shot to give you a good balance. Does that make sense? Midpoint rule is the most popular in terms of Riemann sums. Go ahead, Josephine. Oh, okay. Hey, so what would this one look like? What's the midpoint of 2 and 4? 3. Go up, look, stop. Cut left, cut right? Now look what you got. Part of it's. Now let me tell you what I couldn't ask on the final, or on your test. And I'll get your question, Josephine. I couldn't ask this. Is that an overestimation or underestimation? Because you'd be sitting there trying to what? I can't tell. I don't know if this was what? More than that, right? Is that area more than, right?
Hard, yeah.
It'd be hard to tell. Does that make sense? Now, have mathematicians come up with theorems about graphs that are concave up? And whether a midpoint rule gives they have. They've explored this. They wanted to know, does midpoint rule for concave up curves increasing or decreasing actually give an overestimation or underestimation? But we don't have to worry about that at this point. Go ahead, Josephine.
Is that how you apply the end to figure out how to do the rectangles?
How do you apply the, what was
The
that?
end, like you know the end. to
Oh,
figure
so
out-
this means how many rectangles you'll build, and they will give that to you. That means how many subdivisions you're gonna use. So when there's 2, you and I are looking at this image and go, okay, that means I need to use 2 of these, right? Cool. Now, I have a question for you, Josephine. Do you want a math formula? So you can figure out how many you're always gonna use every time?
Well, I'm more concerned with like how do you figure out where to put your rectangles?
Oh,
You know you're gonna have two. I mean like
So,
that would be a simple example.
they have to be, it was from 0 to 4, right?
Yeah.
And so we had to use 2 of them, right?
So you just figure out the
Well, what did you think? Were we gonna build one like right there and then one like that? That would be kinda weird, wouldn't it? If you gotta build 2 rectangles in here. You gotta go from 0 to what? 4. So should I build one here and then one like that? And then the other one's like this? What would be your logical idea?
just right in the middle.
Yeah, right in the middle. Does that make sense?
So does the midpoint rule always use n equals 2?
No, depends on the how many.
Depends. But I think you want a formula for this, so I'm gonna give it for you. Ready? So if you take this b minus a, what was it? What if you subtracted these right here? And you divide it by this number, they'll tell you how many rectangles you gotta make.
What is D and what is A?
If I call this upper value b
Oh, B.
and this lower value a,
Uh-huh.
I can make a formula for you, Josephine, so it's easier for you. That's A, that's B. And B minus A would be what? 4 minus 0? Now, how many did they have right here? They said n equal what? 2? And this will tell me how many you're gonna have to, what's gonna be the width of each subdivision. That will be, ready? Call that change in x. In this case, though, Josephine, for your notes, did I use the letter t here? I never wrote it here, but I changed it to a t squared, where the function was r equal to t squared. So that would be your change in t. That way you'll never be confused. So watch this. Let's say you went from 0 to 16, right? You had a graph from 0 to 16, it went like this. Cool? So B would be 16, A would be 0, and then I said, you need 4 subdivisions. Could you tell me what the change in the t would be every time? So if it'd be 4 subdivisions, it'd be 16 minus 0 over 4. So what is that number?
4.
So you, every 4 tick marks, you would build a rectangle. There you go. Cool. But was everyone in here be able to do it like logically? Just to go, oh, I gotta go from 0 to 4, I need 2, I just cut it what? Right down the middle? Is that what I cut that?
Isn't delta t dt, right?
That's right.
Okay.
That's meaning the change in the t values. But that's a formula, right? Wouldn't that work every time? So, but if you want a formula to say, I wanna know how far I'm gonna have to go change in this direction to build my what, rectangle? This could always work. Does that make sense? Cool. Hey, now what do we get for our first rectangle? What's the width?
1.
Oh wait, look at our image, everyone. If I call this part the width. 2. What's the
Oh, yeah,
length?
with 1.
Gotta plug that number in, right? 1 squared plus, what's the width?
2.
And look over here, the width is still, is it 4 or 2?
2.
See that? How wide is that?
Two.
That's a width of 2.
Well, like this
Now, is there a math formula for every one of these widths? That's it, if you ever wanna use it, right? I mean, if you wanted a real formula, always put it out would be the width every time. The change in the x will be your change in t will be your width. So make a note of that, Josephine. You go, I can always use that formula to find my width every time. Because you can do width this direction, change in t, change in x. But to get this, I gotta plug it where?
At 3.
Into
9.
the original,
So
which
9.
is, so what's this number, Owen?
19, 20.
Yep, because 3 squared 9 times 2 is 18 plus 2 is 20. Which one of the three is probably closest to the real answer? The midpoint rule, why?
Cause it's between.
It's got like a
it's
bounce.
Between 30 and 14.
You got, that's one way. And look at the image, like, lost some, but I gained some. I lost some, but I what? Gained some. The more you do that would be more. But see, a lot of you have a good idea. You go, yeah, but why don't you take these, add them together, and divide by 2, right? She's gonna do it.
That's 22.
Oh.
Is that right? Yeah, anybody curious
Add
what the
them.
exact answer is? You must be.
Divide by 2.
Can we talk about that?
22.
Come on, you must be curious. What's the exact answer? You can find it through calculus. And you go, what do you do? Right? Maybe I shouldn't do this because the author waits a whole nother section to show this, but why not? I'm sure you're all curious, right? Some are laughing, like, yeah, I know, we can do it now. Let's find the exact answer. I go like this. What were the numbers? 0 to what?
4.
What was the function I was using?
T squared dt.
T squared dt. Now, we spent the whole hour doing antiderivatives, right? Right, everyone? All that time doing antiderivatives. What's the antiderivative? T squared.
T cubed divided by 3.
Now, don't forget something. You got to put your what?
C.
Plus c. Now we'll talk about that. Plus c. Because you go, wait, aren't we supposed to get definite answers? Watch what happens. So when there are numbers there, these are definite answers, right? Something cool's gonna happen. But I'm gonna put my plus c for now, because this is the first time you and I are doing this. This symbol is gone. And when it's gone, it's gone. We found the antiderivative. So what I want you to do is go off to the right here and put a vertical line. At the top of your vertical line, if you want to put little hooks on it, you can. Some mathematicians do. At the top, put that same top number. What is it?
4.
4. And at the bottom, put this number. Now, what do you think we'll do with these numbers?
We're gonna plug them.
We're going to plug them in for what letter?
C.
C.
Oh, not for C.
C.
For T, right?
To
Because
find
really, I didn't write it. That's T equal to 0. That's T equal to 4.
4, yeah.
That's T equal to 4. That's T equal to 0. Now, I'm not plugging them in here, but I want you to understand, this is like accumulating area. So when you do this, we're going to subtract the two values we get. So we'll plug in a 4, get the number, then we'll subtract the value you get when you plug in a 0. But this will give us what kind of answer? Oh, not approximate, but what? Equals exact. And it's probably going to be around, Amber, what was your number again? What was between this?
22.
So it's probably around 22-ish, 20-ish, right? Let's see what we get. So I'm going to plug a 4 in here. What's 4 cubed over 3?
21.3.
Oh, yes, 64 thirds. Do y'all agree? 4 cubed is 64. Now I have to put plus what?
C.
See? That was from plugging the 4 in.
You have to
That was from plugging a 4. Now, do you remember I said put a subtraction sign?
Uh-huh.
Or I'll put a minus sign. Now what number do I have to plug in?
0. 0.
Plug in 0. What, for what letter?
T.
What's 1 cubed over 3?
Not 1. 0 cube.
I mean 0 cubed over 3?
0.
0 plus 8.
And my favorite part, I hope it's your favorite part, what happens to those C's?
The cancels out.
So everyone, ladies and gentlemen, guess what happens whenever you do, this is called a definite integral? Guess what happens every time you do a definite integral, what happens to the C's?
I can't swallow.
So a lot of you aren't even gonna write the plus C when you do definite integrals, because they're gonna what anyway?
Cancel out.
Cancel out. Does that make sense?
So it's just 64 divided by 3. And then
So what's 64 of a third about?
21.33.
That's exact. So and what's the exact area?
21.3.
Now, can we have fun and do this on our calculator? Can we all do this on our calculator? You got yours? Everyone got it? Would you go to y equals? Josephine, you got yours? Let's have fun. Go to y equals.
Mm-hmm.
What's the curve again? X what?
X squared.
X squared?
Mm-hmm.
All right, hit graph. I'll wait till you do it. Y equals x squared, hit graph. If your window's out of whack, zoom 6, right? Unless you want to go from 0 to 4, but no, zoom 6, 0 to 10, that's okay, it's a nice window. Go to second calc, which is that trace button. Second trace. Which one has that integral symbol? Which one?
7.
Go to 7. What's the first question?
Lower
Lower
limit.
limit.
What's the lower limit?
0.
0.
It's 0, hit enter. What's the upper limit?
4.
4.
And what will it do? It should go, oh, cool. Isn't that cool? Don't forget about this. This is a little cool button. Did it work? 21.3, and there's probably a 4 at the end. All right, it gets that round. Remember, we sometimes get the round off error at the end.
Oh, yeah, I don't get it.
It didn't work.
Hold on.
What?
Do this, and then do lower limit.
Oh no, just pick the number. Let's start over. There it is. Graph.